Nanotechnology is thought of as a buzzword, but not many people fully understand what it is. Can you help define and introduce nanotechnology?
Yeah, I mean, I think you're gonna probably get completely different responses from a lot of different types of scientists. But when I think or hear about nanotechnology, I tend to think about having this really kind of special scientific toolkit that allows us to really simultaneously think about big and small at the same time. What I mean by small is that a nanometer is about a billionth of a meter, which is super, super tiny. A lot of people tend to use the example that a strand of hair, human hair is about 80,000 to 100,000 nanometers thick, and so if you shrink that by another thousand, that's really at the size scale that we're trying to operate at. At the Broad Stem Cell Research Center, we have a lot of amazing colleagues who are super incredible scientists who are looking to ask really important questions and working to understand how stem cells behave and what drives those behaviors, how to really repair issues that could lead to disease or develop different types of treatments for the future. But in order to kind of operate in that space and accelerate that type of research, they're going to need different sets of tools. They need the right kind of screwdriver, basically, or the right kind of wrench that allows them to kind of look under the hood of the cells. And nanotechnologies offer kind of a way to kind of unlock those capabilities because they're at that right size scale. You kind of think about it in terms of Marvel movies, right? Because there are two specific characters in the Marvel Cinematic Universe, Ant-Man and the Wasp, who are deceivingly kind of powerful. They are just normal people with these suits that give them this amazing power to shrink themselves or even grow. But when you think about when they shrink down to the size scales that we're talking about, that allows them to really see and interact with the world in new ways. And if we could give that same kind of superpower to a stem cell scientist or a clinician, we allow them to really peer into the inner workings of stem cells and how they might be able to manipulate them in new ways, which allows them to kind of learn and discover hopefully some pretty exciting things in the future.
So what are a few sectors nanotechnology stands to improve and even revolutionize? And what are some day-to-day ways that nanotechnology impacts our lives?
Yeah, well, I mean, nanotechnology and nanoscience are at their core really interdisciplinary. And it's really because, they're this amalgamation of chemistry and physics and biology and engineering that they inform and have their fingerprints on a lot of the different devices and technologies that that make our world go right now. It's really the reason why we were able to have this conversation with enough computer power to broadcast this this discussion, and it's really how it informs how we kind of can utilize and store energy more effectively in the form of the batteries that help our cell phones last so long, or give us enough range in our electric cars in the future to hopefully help us change how we can interact with the environment. In terms of medicine, I think the most present example is, the COVID-19 vaccines that many of us have, really benefited from, and having received them so that we can, hopefully get back to some kind of normalcy after being put through some tough times over the past couple of years. And so, having those types of treatments as quickly as they were developed wouldn't have been possible without the ability to really work with materials at the size scales that we're talking about, that can essentially be designed to act essentially like nanoscale suitcases that can protect vaccine components and allow them to do their job more effectively. And so it's these types of methods and strategies that are really going to help us, address bigger challenges kind of moving forward.